Hey guys, Varun here again. So today I'll be talking about the L Systems add-on that I have made for Blender. I don't think many of you are familiar with L Systems. So L Systems are Lindenmayer systems that I use for generating fractal patterns. These patterns can be found multiple places within the ecosystem that we live in. These are used for generating trees, snowflakes, and various other fractal patterns or patterns that repeat themselves or branch off from one simple pattern. So we'll just get to the add-on, but I'll just give you a brief as to how it works. You can find the add-on on my GitHub page. It has 2 releases so far, so I'll be updating it in the future too. Right now it's a 2D add-on. That means it can only generate patterns in 2D and not 3D, so I will be working on that aspect soon enough. But yes, on the GitHub page you can see that there's a learn link that will lead you to the Wikipedia page, and the Wikipedia page has a good detail about how it works and what it actually does. So you can see that we have a grammar. A grammar is just the set of rules that are followed to generate a particular system. And then the grammar just branches off. That is the number of generations we give to the tool. So based on the number of generations and the grammar that we have, we generate patterns. Right now, a limited number of grammar is supported, which can also be found in the GitHub page. Like a whole detail for that thing is available in the GitHub page. This one is not yet implemented, as you can see that the checkbox is not ticked, but other than that everything has been implemented successfully. So going to the interface itself or going to Blender itself, how do you use this add-on? It is very simple. You can just select any object or you can just add a cube each time, because that's the easiest way to access this add-on. So you just access the cube. I'll go into top view, and suppose I want to generate a system. Now right now by default you can see that the system is AAB BA, and there is no actual grammar. There's just one axiom. Axiom is the starting point of the grammar or the system, and then we just branch off. So A will be replaced by AB and then B will be replaced by A per generation. So this is the number of generations or the number of iterations that we are going through. These are the number of rules. You can increase them up to 5. So I have like limited the number of rules that can be used. So yeah, angle is the angle that you want to rotate the system by after each step, and the length is the just length of the system. By default it's 1, so it will be equal to one segment of the grid that you see. This whole segment will be of one length. So we can just click on generate system. Like you can see that it does nothing. It just generates a straight line that has 1 2 3 4 5 6 points. So suppose we want to generate something more interesting, I'll delete the thing, I'll add another cube, and I have a bunch of presets so that you can refer to these. So I'll just generate a Kosh snowflake. I'll just select this and then click on generate system. It takes a while, but now you can see that this thing has been generated. It's a mesh and it has been generated. So again, the length of each segment is 1 unit or 1 unit in the grid that you can see right now. And this is a snowflake, and you can use this anywhere. Suppose you want to generate more patterns, just add another cube or add another object, just a mesh type, any mesh type. Add this, then we'll select the Kosh curve or the Sierpinski arrowhead curve. I'm very sorry I butchered the name, but yes, you'll generate it. Like you can see that this is the curve that we have generated. If I want to generate a bigger curve than this, right now you can see that it's pretty small. So if I want to generate a bigger curve than this, I'll just increase the number of generations that I have. And I'll just click on generate system. Now you can see that the original curve we had is this. It's only this, and the curve on the 6th generation is this. It's a repeating pattern. So you can also generate a bunch of non-repeating patterns, that is example, a fractal plant. I'll generate this thing. This takes a lot of time because there is a lot of branching that is going on in this particular system that we will see once it generates the whole thing. It may seem stuck, but it is not actually stuck. It is generating the whole thing. So now you can see that it generates the whole thing. And this is a fractal tree that we have. It has been generated based off of the mathematics or some rules that we have given to the system, or the, you could say, Lindenmayer system that we have made. So yeah, these are the two rules. This is the number of generations. That is the number of iterations that we have. I'll generate a simple one again. I'll generate one fractal binary tree. This one is simpler, but it is like you can see that we have a fractal binary tree. If I want to generate, say, more of such patterns, I'll just get another cube. I'll just displace it. The center point of the patterns would be the center or the like origin location of the particular geometry you are generating this on. I'll just increase the number of iterations to 8 or 9, and then I'll just generate the system. So again, this one was the binary tree, and you can see that the tree has been generated. Increasing the number of generations did nothing, just increase the length of it. So yeah, we can generate any pattern that you want. So as you can see in the Wikipedia page, this is the fractal binary tree. This is the Sierpinski triangle. This is the arrowhead curve. This is the dragon curve. All of these are by default generated or by default included in the add-on. All the examples on the GitHub page. You can just generate any of them on your own convenience and learn more about this thing. So thank you very much for watching, and that was it.